Hello, business calculus students. Today what we're going to be doing is using the chain rule to differentiate these expressions right here. So, just a reminder, what we have is dy dt. Here's the chain rule. It's dy dz times dz dt. So that means I need to take this and rewrite it using an inside function z. Well, a really good choice here is the exponent for number 1, 2t plus 1. And if I do that, then y is going to be 3e to the z. So it's time to apply the chain rule. What I'm doing here is dy dz, the derivative of this function. Well, I've got a 3 out front, that's a constant multiple, times e to the z, whose derivative is e to the z. So I have 3e to the z times dz dt. So I have to take the derivative of this. This is a linear function, so its derivative is 2. I can't leave an answer with z. I have to have an answer with t at the very end. So I'll plug in what z is. So let's see. 2 times 3 is 6. So I have 6e to the 2t plus 1. Yay, that's our derivative. Let's do that a couple more times. So let me get rid of this stuff. Let's do number 2. Again, I'll write down the chain rule. If you need help remembering the chain rule, just think of these two pieces of the derivative canceling out. So you're left with dy dt. I'm working on number 2. I need an inside function. Best thing to use is the stuff inside the parentheses. That means that y is going to be the natural log of z. Okay, time to fill these in. I need to find dy dz. That's the derivative of the natural log of z. And if you remember, when we differentiate natural log of our variable, we get 1 over our variable. That's 1 over z times the derivative of this function. I'm going to put stuff in parentheses here. So the derivative of this, I need to use the power rule to get 3t squared plus the derivative of t. If I think of this as a linear function, it has a slope of 1. That's 1. Again, I cannot end with z in my answer. So I have 3t squared plus 1 on the top, and then I plug in what z is, which is t cubed plus t on the bottom. There's my derivative. Whoops, didn't mean to do that. Let's get rid of all that. Whoa! Not all that. Let's get rid of all that. And let's do this one more time. So, for 3, again, we write down the chain rule. We need an inside function. That'll be z equals 5t plus 2. And that means that y will be z to the 7th power. So we're ready to differentiate. dy dz, we've got this. We use the power rule. 7z to the 6th times, now we need dz dt, the derivative of this. That's just 5. Putting the 5 and the 7 together, we've got 35. Plugging in what z is, we've got 5t plus 2 to the 6th power. And there are 3 examples of how to use the chain rule.